Hello everyone. Today we're going to start homework 5, which is your first lesson on factoring. Homework 6 and 7 are also on factoring, and then homework 8 is going to be those 3 lessons all together. I'm kind of taking my time through this factoring portion because, as you can see, you're going to be using this in pre-calculus in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different homework assignments in your pre-calculus class. Not only are you going to need factoring in a lot of your pre-calculus homework assignments and lectures, you're going to need factoring going from here on out. You're going to be using it in Calc 1 and beyond. So this is a really important thing to learn. If you get good at it now, it makes the rest of your math career, the rest of your math learning, so much easier. So in this section, we are going to factor trinomials in this form right here: x squared plus bx plus c. So it gives you some examples here. And then it says, notice that for these trinomials, the coefficient of the squared variable is 1. That is what makes these, in quotes, your easy trinomials to factor. When we go to homework 6, you're going to have an a out in front, so it'll be ax squared. And same thing with homework 7 when we actually do hard trinomials. So for today, all of these coefficients are going to have a known 1 right there in front. Okay, and that's what makes these all easy. Now, what we are doing is we are basically, so when you were given something like this right here, you would FOIL it out, right? So we would do x times x to get x squared, x times 1 to get 1x or just x, 3 times x to get 3x, and then 3 times 1 to get 3, and then we would combine our like terms, which is our x variables here, and we would get this answer. What I am doing now is we are starting at this form here and going backwards to its factor form. So we are unfoiling, if you will. So factoring a trinomial in the form of just x squared plus bx plus c, it says you want to find the product of these numbers as c and the sum of these numbers is b. So what does that mean? What we're going to do is we're going to make these little x's, and it's just a visual way to figure out what we're doing. So even though we do have an a out here and it's 1, it's going to set us up later. So this is always going to be our a times c. And then we'll put our b term in this bottom portion. And then what we're going to look for is 2 numbers that add up to our b, but multiply to our ac. And we'll use those numbers right here. So, for example, example 1 says factor. We have got x squared plus 7x plus 10. So, my a is 1, my b is 7, my c is 10. So, my a times c is 1 times 10. So, we've got 10 here. My my b term is 7. So I'm looking for 2 numbers that add up to my b, add up to 7, but multiply to my ac, multiply to my 10. Now, unfortunately, if you're not good at your multiplication, this is going to be tricky for you. There's only 2 ways to multiply to 10. 1 times 10 and 2 times 5. Luckily, 2 times 5 gets me to 10 and then adds up to 7. Right? 2 times 5 is 10. 2 plus 5 is 7. So now this is going to factor to x plus 2 and x plus 5. And so that is my final answer. And so how could we check this? We could just FOIL this out, right? If I have x plus 2 times x plus 5, x times x gets me x squared. X times 5 is 5x. 2 times x is 2x. And 2 times 5 is 10. And when we combined our like terms, we get x squared plus 7x plus 10. So it works. You can check all of these. This is the only one I'm going to check, right? But you could check every single one of these answers to see if you've got the correct answer. And then down here it says that since multiplication is commutative, the factored form x squared plus 7x plus 10 can be written in either x plus 2, x plus 5, or reversed x plus 5, x plus 2. A lot of times people will ask me, well, what happens if we switch these? And it's perfectly fine. Okay, as long as you have a plus 2 and a plus 5. Because 2 times 5 gives me 10. 5 times 2 also gives me 10. It doesn't matter the order. So this one was kind of the most simple one because you had all positives. There's 4 things that can happen, and so I put this here. If you're good at your multiplication, this portion here should honestly just kind of make sense. Okay, but if we're not good at our multiplication, here's kind of some helpful hints. When you have a positive and a positive, we're going to call this our first case. Okay, if you have positive and positive, it leaves both of these here to be positive numbers. My second case is when you have a positive C, but then a negative B. When that happens, you have to have 2 negative numbers because 2 negatives multiply together to become positive, right? Negative 2 times negative 8 gives me a positive 16, but when I add them, we get that negative number. Okay, so that's what it means by same sign. They're both negative. Those seem to not be too hard or too difficult. Where we make the most mistakes is our cases 3 and 4. With cases 3 and 4, when you have a negative C, the only way to get a negative number is to multiply a positive times a negative. So your signs here are going to be different. And so then you want to look at your B term. If my B term here is positive, then my bigger number is also positive. Okay, but you can see between 3 and 4, this is a negative 16, a negative 16. The only difference is it's a plus 6x and then a minus 6x. So now, when you have a negative number here, we still need a negative times a positive. But now because my B term is negative, now my bigger number is negative. Okay, so if that's helpful, use it. If it's not, just ignore it. So example 2 is just going to be these 4 cases all kind of mixed together. So on A, we have x squared plus 12x plus 30. So this is going to be a case 1. And actually, let me do this in a different color. Okay, this is a case 1 because you have a positive and a positive. So it means both of my numbers here when I factor are going to be positive numbers. So let's go into our x. My A times C is 1 times 35 to get me 35. And then my B term is 12. So what 2 numbers add up to 12, but when I multiply together, give me 35? 35 only has two factors. 1 times 35 and 5 times 7. 5 times 7 gives me 35. 5 plus 7 gives me 12. So this becomes x plus 5, x plus 7. And again, we could FOIL this out, multiply it, check it. On B, now we have a case 2 because this back one here is negative, but my back one's positive, my B is negative. So the only way to get to that is with two negatives. Because negative times negative will give me that negative 7 or a positive 70, but when I add, we'll get that negative number. So my A times C is 1 times 70. My B term is negative 17. So what adds up to negative 17, but when I multiply gives me to a positive 70, it's going to be negative 10 and negative 7. Okay, that one's got a lot more multiples. You can do 5 times something. You can do 1 times 70, 2 times 35. That one's got a lot more. Okay, so just kind of play around with it. It's the hardest part is finding these two numbers right here. So this becomes y minus 10 and y minus 7. And just so you are aware, on my math lab, you've got to pay attention to those variables. If you accidentally put this as x minus 10 and x minus 7, you're going to get it wrong. So if they have y variables or different variables, you got to use different variables than x. On C, this one is a case 3 because my C is negative, but my B is positive. So my A times C is negative 12. 1 times negative 12. My B term is 4. So it adds up to 4 and multiplies to negative 12. So on this one, we are going to get 6 and negative 2. 6 times negative 2 gives me that negative 12, and when I add them together, 6 plus a negative 2, that gives me 4. You do have to be careful with those signs, because if you switch them, and you say negative 6 and 2, well, when I multiply, I still get to negative 12, right? Negative 6 times 2 is negative 12, but when I add negative 6 plus 2, that gives me a negative 4, and I need a positive. Okay, so that's why you really got to watch those signs. Okay, so we've got x plus 6 and x minus 2. On D, this is a case 4. Because you've got negative and negative. So my A times C is 1 times negative 42. And my B term is negative 1. So it adds up to negative 1, but multiplies to 47. And that's going to be negative 7 and a positive 6. Watch those signs again. If you switch those signs and you give me a 7 and a negative 6, well, when you add those together, you get a positive 1. Because it needs to be negative 1, my bigger number needs to be negative. So x minus 7 and x plus 6. E, we've got positive, positive. So that's a case 1 again. So I know I'm going to have m plus a number and m plus another number. So my A times C is 1 times 100. My B term is 20. What adds up to 20 and multiplies to 100? And that's going to be 10 and 10. So I've got M plus 10 and M plus 10. Now, when this happens, when you have the same binomials that multiply together to get your trinomial, you do need to condense this to get M plus 10 quantity squared. F is the same thing. This one's going to be a case 2 though, because you've got a positive C but a negative B. So that means I'm going to have W minus something and W minus something. So my A times C is 1 times 16. And my B term is negative 8. So what adds up to negative 8 but multiplies to a positive 16? And that's going to be negative 4 and negative 4. So W minus 4, W minus 4. So same thing. We need to condense that to W minus 4 quantity squared. These two on part E and F, when you can have the same thing and you put them together for a quantity squared, these have a special name. These are called your perfect square trinomials. And when we go to completing the square, these are going to be really important. So we need to remember those throughout this week and next week before we go to completing the square. That perfect square trinomials are your quantity squareds. Okay. So this last page here has a couple different things in it, but it's all basically the same. Any time you are factoring anything, what you need to look for first is always going to be, do you have a GCF? Do you have a greatest common factor? So I told you this time in this lesson, we're only doing, in quotes, easy, right, trinomials, which easy means we never have a number in our A term. Well, in example 3, I actually do have an A. So as far as this lesson's concerned, when that happens, that needs to be a light bulb in your head. I have a GCF. You should be checking these every single time. Do you have one? That needs to be the first thing that pops in your mind. Excuse me. So example 3 says to factor, look for your GCF. On A, they're all even numbers, so I do have a GCF of 2. Now when I take that 2 out, think about dividing all of these terms by whatever that GCF is. So 2x squared divided by 2 is x squared. 4x divided by 2 is 2x, and negative 30 divided by 2 is a negative 15. These are super easy to check. All you have to do is distribute. That's what factoring out that GCF is undistributing. So 2 times x squared gets me back to that 2x squared. 2 times 2x gets me back to that 4x. And 2 times a negative 15 gets me back to that negative 30. So now when I am ready to factor and go into my x, my a times c is not 2 and 30. it is back down here, and this one I have just factored. So now it's nothing different. So my A times C is 1 times negative 15. My B term is 2, not 4. So what adds up to B and multiplies to AC? And that's going to be negative 5 and 3. Oops, see, I just made the mistake, right? What's wrong with my two numbers that I picked? Well, negative 5 times 3 does get me to negative 15. But negative 5 plus 3 equals what? That equals negative 2, and that's not right. So what this should be is positive 5 and negative 3. Okay, that's how easy it is to make mistakes. It's okay. So now bring down that GCF. So I've got 2 times and then x plus 5 and x minus 3. You do have to make sure that 2 is out front though. If you don't have that 2 out front, what you factored was x squared plus 2x minus 15, and I wanted to factor the original. Same thing for B. What is your GCF? We've got 4, 24, and 36. So that makes my GCF 4. But if you also look at this one, you've got 3 y's, you've got 2 y's, and you've got a single y. How many y's can I take out of all of them? And that's 1. So sometimes your GCF is going to have a variable, and that's okay. So now divide everything by your GCF. Move this down a little bit. Okay. So 4 divided by 4 cancels. Y cubed divided by y is y squared. Negative 24 divided by 4 is negative 6. Y squared divided by y is y. 36 divided by 4 is 9. And then here my y's cancel. So now into my x, we've got our A times C is 1 times 9, not the original. My B term is negative 6. So what adds up to B and multiplies to AC? And that is negative 3 and negative 3. So because those are going to be the same, I know this is going to be a perfect square trinomial. And so I'm going to skip that step of writing them separate. So my answer is just 4y and then parentheses y minus 3 quantity squared. Okay, if you need that extra step of writing a y minus 3, and then pushing them together, you can, but not necessary. All right, so we're through about 3.5 pages. And the title of this was factoring and solving. Well, we haven't done any solving yet. All we have done so far is factored. So now the rest of this is solving. When we solve, we really only have one extra step, and it's that zero factor property. So when you are solving, step 1, okay, I'm going to make this into 4 steps. Step 1 is always making sure it's in this form of your ax squared plus bx plus c equals 0. Okay, you want all of your junk on one side of the equation and equals 0 on the other side. Step 2 is going to be looking for a GCF. Okay, you're not always going to have one, but you need to look for it. Step 3 is to factor. Okay, and we're factoring by using that x. And then here is your step 4, using your zero factor property. So when you have something like this right here, this is just this being multiplied by this. If you are multiplying two things together, what this is saying is that one of those multiples has to equal 0. Okay, if you have this right here, the only way to get to 0 is if you have 0 times a number, right? So let's say 0 times 7 or 7 times 0. One of those, either A or B, has to equal 0. So all you are doing is you are taking the multiples and setting them equal to 0. Well, on on example 4 solve, this is already, they've already done the hard part for us, right? This is already in factored form where you've got parenthesis times parenthesis. So all you do for that zero factor property is you set both of these multiples equal to 0. So the first one is x plus 8 equals 0. And then you have x minus 11 equals 0. And then solve. So you're going to subtract your 8 over to get x equals negative 8. And you're going to add your 11 over to get x equals 11. So when it's already factored for you and it tells you to solve, you just got to thank the people. They already did the hard work for you. Now on B, we've got the hard work to do ourselves. So step 1 is, does our equation equal 0? Well, no, it does not. So how do we get that to equal 0? I need to move this over to the other side. So the opposite of a minus 16x is a positive 16x. Now I can't combine that with anything because we got an x squared and we got an x cubed. So this simply becomes x cubed plus 10x squared plus 16 equals 0. So now step 1 is complete. Step 2, do I have a GCF? Well, I can't divide anything into 1, 10, and 16, but they all do have an x, so I can factor out an x here. So that's going to leave me with an x squared plus 10x plus 16. So now I can move on to step 3 and factor. So my A times C is 1 times 16, so 16. My B term is 10. So what adds up to 10 and multiplies to 16? And that's going to be 8 and 2. So this becomes x plus 8, and then x plus 2. Now, on this one, even though I'm calling this, well, it is a trinomial, but it's not a quadratic. This is actually a cubic. And the reason is because it's got an x cubed instead of an x squared. Still treat it the same. But what this exponent does tell me is that this tells me the possible number of answers I have. And you'll actually learn more about this in your pre-calc class, but that tells me the number of possible answers I have. And in this one, we actually do have 3. What I need to do, I've done step 3, so now I'm over here to step 4. I need to set each of my multiples equal to 0. Well, how many multiples do I have? I've got x, because we could multiply that x right in, right? We could distribute it. So that's a multiple. We have x plus 8 and we have an x plus 2. So I'm setting all three things equal to 0. So this first one here is just simply x equals 0. X's are nice. Then we have x plus 8 equals 0. And we have an x plus 2 equals 0. So subtract your 8 to get x equals negative 8. And subtract your 2 to get x equals negative 2. Those are my three answers. The last bit here is to find the x-intercept of a graph. Sounds confusing, sounds like there's a lot of work, but this is actually what we've been doing in example 4. It's no different, just different wording. When you want to find the x-intercept of anything, how do you do that? You set y equal to 0 and then solve for x. So in A, we've got y equals x squared minus 9x minus 22. So now I've got 0 equals x squared minus 9x minus 22. So now step 1 is already done, right? It equals 0. Step 2, does it have a GCF? I can't factor anything out of 1, negative 9, and negative 22. And they don't all have an x term, so I don't have a GCF. So now we're going to go straight into the factoring. So my a times c is 1 times 22, so negative 22. My b term is negative 9. So what adds up to negative 9 and multiplies to my AC? It's going to be negative 11 and 2. Negative 11 times 2 gives me negative 22. When I add, we get negative 9. So now I've got 0 equals x minus 11 and x plus 2. So now I go on to step 4, use that zero factor property. So I've got x minus 11 equals 0 and x plus 2 equals 0. I'm going to add that 11 over to get x equals 11. And I'm going to subtract that 2 over to get x equals negative 2. Now those are your x-intercepts. I don't remember how your homework's going to ask for it. If it wants it as an ordered pair, it's telling you what your x equals and what did you plug in for your y? You plugged in 0. So if it needs an ordered pair, it says 11, 0 and negative 2, 0. And what you have found is that when you have a parabola, it is telling you where it crosses that x-intercept. So now this point is at negative 2, and this point here is at 11. Same thing on B. We've got y equals 3x squared minus 15x plus 12. So we're setting 0. We're setting y equal to 0. So 0 equals 3x squared minus 15x plus 12. So that takes care of step 1 equals 0. So now look at step 2. Do I have a GCF? In this case, I do. Hint, hint, in this lesson, anytime you have an A, anytime you have something in front of x squared, you're always going to have a GCF. So my GCF is 3. So when I factor out a 3, that leaves me with x squared minus 5x plus 4. So now factor. My a times c is 4. 1 times 4. My b term is negative 5. So what adds up to my b and multiplies to my ac? And that is negative 4 and negative 1. Negative 4 times negative 1 gives me a positive 4. When I add them together, we get that negative 5. So I've got 0 equals 3 times x minus 4 and x minus 1. Now remember what I said over here in b. Whatever that exponent is tells you your highest possible number of answers. Because I have an x squared, because of this x squared, it means I only have 2 possible answers. When you take a GCF out of just a number, that's not an answer. Maybe instead of putting an x, let's just do this quickly. Okay, and if you did, you'd get 3 equals 0, and that doesn't make sense. So that's not an answer right there. So I'm going to set x minus 4 equal to 0 to get x is 4. And if they want that as an ordered pair, that's 4 comma 0. And we've got x minus 1 equals 0. So that's going to give me x equals 1, or an ordered pair 1 comma 0. Definitely ran out of room there. Sorry about that. Okay, and so what does that graph look like? If you have your parabola here, actually let me kind of go. Okay. Your parabola is going to look something, not like that, something like this, where it is crossing at 1 and at 4. All right, so a lot of information in this one. You do have a longer homework assignment. It's 15 problems, I believe. And these are going to be all mixed up. So how are you going to know when to factor and when to go that extra step and solve? It's pretty easy. They're either going to tell you to factor, which means just the multiples, or it's not going to have an equal sign. So you are factoring when there is no equal sign. I don't know if you can read that or not, but factoring has no equal sign. You can't solve it. It's not possible. It's not an equation. When it has an equal sign, that is when you are solving. Okay, and the instructions are going to tell you factor this or solve this. You can also just read the instructions, but it's also a hint. If you don't have an equal sign, you can't solve it because it's not an equation. If it has an equal sign, you go that extra step, set it equal to 0, and solve. If you have any questions, please feel free to contact me. Bye, guys.